Okay, since we know that the sum of the angles of any triangle is 180 degrees, we can add up the angles of this triangle, angle C, angle E, and angle D, and get 180. It's this right here. We can also add up the angles of this triangle, C, B, and A, and get 180. And if that's true, then E, D, and C, these, is equal to the sum of these angles because they both equal 180 degrees. So then, if we subtract that angle C out of there, which we're allowed to do, on both sides, a little bit of algebra thrown in there, we get angle E plus angle D equals angle B plus angle A. I'm a little bit rusty on one thing about geometry, whether that needs to be a congruency sign, and I think it does. And I think this needs to be a congruency sign too. Anyhow, moving along, we know that these two angles, E and D, are the same because they're across from congruent sides of an isosceles triangle. It's this statement right here. We also know that A and B have the same measure, they're congruent angles, since they are opposite congruent sides of another isosceles triangle, and that's this statement right here. Okay? So I have to move on to a new slide real quick, and we will take the fact angle E plus angle D equals angle is congruent to, angle A plus angle B. And we'll take the fact that angle E is congruent to angle D. And we'll take the fact that angle A is congruent to angle B, which we've all shown on the previous slide. And we can take and we can substitute in angle E in here for angle D. It's on a nice proof, you don't write that, but I'm just explaining. Angle E plus angle E is congruent to, and we can do this over here, put in A where we have the B, and we can get angle A plus angle A. So that's 2 times angle E, it's the same as 2 times angle A. You can just divide both sides by 2, again throwing in a little bit of algebra, and we get angle E is congruent to angle A.